Hey students, so I wanted to show you how to use a solubility rules chart. So right here, this is an example of a solubility rules chart. There are many you can find online. They come in different shapes and sizes. This one's the one from Apex, so I want to show you how to use this one. Once you get the hang of it, it makes a lot of sense. But at first, when you look at it, it's like, oh wow, gee darn, what's going on? So let's jump right into it on the solubility rules chart. So you're going to use this in your lab for chemistry, and you're going to use this to figure out if the product of these double replacement reactions or the product of a chemical reaction is soluble. So remember that you're looking at the product. So when you're doing the lab, you're looking at the product, if it's soluble or insoluble. We're not looking at the reactants, we're looking at the products. Okay, so we're going to look at the rules. Rule number 1, compounds containing group 1A ions and NH4 are soluble. So first of all, we got to remind ourselves, what is a group 1A ion? In order to answer this question, you need to have your handy dandy periodic table next to you. So make sure you have a periodic table. I have one right here. So if you look at our periodic table, remember that the periodic table is organized in many ways, in two main ways. It's organized horizontally into periods, right? And it's also organized vertically into groups, right? And so this said group 1A ions. So notice there's a 1A. These are the group 1A ions. So what it's saying is if it has hydrogen, lithium, sodium, potassium, rubidium, cesium, or francium in it, it's going to be soluble. Okay, so let's scroll back up there. Oops, get rid of those. Compounds containing group 1A ion, lithium, sodium, potassium, rubidium, cesium. Good. And NH4. NH4 is ammonium. That'll also be soluble. Okay. Rule 2, compounds containing chloride, bromine, iodide are soluble, right? And so remember, if we look at our periodic table, those are in group 7. Chloride, bromine, iodine, also soluble. Okay, so let's do some quick examples, and feel free to pause the video. Actually, let me, before we do the examples, the exception is these are insoluble when they contain silver, lead, or mercury. Okay, so even if it has, for example, lithium, if it also has, oh wait, that wouldn't work. If it has chlorine, for example, if it has silver as well, it's insoluble. So the exception overrules that rule. Okay. All right, let's do a couple examples real quick, and feel free to pause the video as we do the example. So number 1, the game is soluble or insoluble, so you have to figure out using the chart if this compound is soluble or insoluble. The first one is potassium chloride, soluble or insoluble. If you look at the chart, hopefully you pause the video, give yourself time to answer. If you look at the chart, it contains potassium, so far it's soluble, and it contains chloride, so it also says it's soluble. So this is for sure soluble, like for sure. We could say double soluble. There's no such thing, but this is definitely soluble. All right, let's do another one. Silver chloride. Take a moment. Feel free to pause the video if you need to. Now, chloride, that's soluble. It has chloride, so maybe it is soluble. But silver is one of the exceptions. So in this case, it's actually going to be insoluble. Let's move on to rule 3. Compounds containing fluoride are soluble. Okay, that's good to know. The exception is fluoride compounds with group 2 elements are not insoluble. Also, lead fluoride is insoluble. So let's look at our periodic table, group 2. Group 2 is right here. So if it has beryllium, magnesium, calcium, strontium, barium, radium, or lead, lead's over here, and fluoride, it's going to be insoluble. Okay? So let's do some examples. So examples, potassium fluoride. Pause it if you need to so you can do it yourself. It has fluoride, it's soluble. Is potassium in group 2? No, it's not. It's in group 1, so it is soluble. Okay, so this one is soluble. We'll do SOL. Let's look at calcium fluoride. Soluble or insoluble? Again, fluoride, so it should be soluble. Let's see what group calcium is in. Uh-oh, calcium's in group 2. So calcium fluoride is going to be insoluble. Insol. Okay, moving on. We've got to move forward here. Number 4, compounds containing sulfates, SO42 minus, are soluble. Okay, that's great. And the exceptions are these ones: barium sulfate, lead sulfate, mercury sulfate, and calcium sulfate. Okay, that makes it easy. This is straightforward. So if I give my examples here, what about lithium sulfate? Well, we know sulfates are soluble. Lithium sulfate's not an exception, so therefore it's soluble. And then what about mercury sulfate? Well, there it is right there. It's an exception, so it's insoluble. Easy peasy. Rule number 5. Acetates, nitrates, chlorates, and perchlorates are soluble, and there's no exceptions. So let's do our examples real quick. I'm going to do silver, nitrate, NO3, nitrate, NO3, soluble, easy peasy. And I'll do another one just for the heck of it. Potassium acetate. Acetate, it's soluble. Easy peasy, soluble. Now, we're going to move on to Rule 6. So the table kind of goes this way. Let's look at Rule 6, and now we're talking about insoluble. Hydroxides are insoluble, with the exceptions of NaOH and KOH. So if I give you something like iron hydroxide, well, that's going to be insoluble. It's not an exception, so it's insoluble, right? Because we're on this side of the table now. We're on the insoluble side. And then, of course, if I put sodium hydroxide on here, well, that's an exception. So that is soluble. All right, rule number 7, last one. Carbonates, phosphates, and oxalates and sulfides are insoluble, with the exceptions being compounds containing group 1A ions and ammonium, NH4. So remember, group 1A ions are these ones, and NH4 is ammonium. So if I give you magnesium carbonate, well, a carbonate that's insoluble is magnesium group 1A? No, it's not. It's group 2. Therefore, it's insoluble. And we'll do one more. Potassium carbonate. It's a carbonate, so it should be insoluble, but group 1A ions, potassium, it's in group 1. Group 1A, therefore it is actually soluble. Okay? So make sure you have your periodic table and your solubility chart when you're doing this lab, and hopefully that was helpful.